today?
How's it going?
Good.
Good. Pretty much today, we're just trying to review over all the stuff we've done right now. So I have a packet that I have to complete as a study guide for my big semester final.
Okay.
So
I will let you direct. You can start at number 1, or you can start however you feel necessary in order to cover the packet before.
Okay. I'll just do the ones that I've forgotten how to do exactly since it's been a while.
Okay.
The ones I have questions towards.
Okay.
So I have a given of negative 535 degrees. And find a coterminal angle between 0 and 360, it's asking.
What's coterminal mean?
I have no idea, but I'm pretty sure it has to be on the unit circle, so I have to add.
It's a multiple of the unit circle. In other words, any multiple of 360 degrees. Let's say I gave you an angle of 30. Okay. Well, 390 is coterminal to that. 750 is coterminal to that. 1110 is coterminal to that. Minus 330 is coterminal to that. Get it?
Yes.
Okay, so they want the angle that's coterminal to that is between 0 and 360. In other words, the one in the unit circle. So how am I going to find that?
I would add 360, right?
Okay, let's try that. If I add 360 to that, I get minus 175. Is that in the unit circle?
No, so I'd have to add another 360.
Correct. And I get 190. No, that's not what I get. I get...
Oh, I'm going to get it real quick. 360 minus 175. 185.
That is in their required angle. In other words, they wanted the angle that was between 0 and 360.
Yeah.
It was coterminal to that. And here's the thing. All angles that are coterminal have the same trig functions. In other words, the sine of minus 535 is equal to the sine of 185. Which is...
Then I have to find the reference angle.
What's that?
Then I have to find the reference angle.
They ask you to find the reference angle?
Yes.
Okay. Well, most school systems put a little more emphasis on reference angle than I do. But I know what they're talking about. In other words, they're talking about an angle that goes around 185 degrees.
Okay.
Since that's 180 degrees, what is this angle right there?
5.
Correct. That's the reference angle of which they speak.
Okay.
Now, going back to the original problem, minus 535. Minus angles go clockwise, positive angles go counterclockwise. So if I wanted to know where that actually was, I would go around once, that's 360. And I'm still at a negative angle, so I go around twice, and I get to right there.
Okay.
Okay? And that gives me that 5-degree reference angle in the third quadrant. Or 185 degrees. In other words, if I started from X and went 185 degrees around, I would get that same angle. Now, the trig functions of 5 degrees in the third quadrant are going to be the same as the trig functions of 5 degrees in the first quadrant. The only difference is you have to pay attention to all students take calculus. In other words, the absolute value of the number will be the same, but the plus or minus sign might be different.
Okay.
Because we're in the third quadrant. Remember this angle, minus 535 degrees, is in the third quadrant. It doesn't start out that way, but after you add 360 twice to it, it ends up in the third quadrant. And you always want to bring these angles into the unit circle. You don't want to deal with angles that are outside the unit circle.
Okay.
In general. I mean, there's a few exceptions to that, like if you have minus 60 degrees, the sine of minus 60 or something like that. But
yeah.
When you're dealing with numbers that you can clearly add 360 to, and it's still not in the unit circle, and then when you add another 360 to that, it gets to the unit circle, we'll deal with this angle right here. That's going to give you all the same trig functions.
Okay.
All right.
Okay, the next one I have is write an equation of a sine function with the amplitude of 5 over 3, a period of pi over 4, a phase shift of pi over 3, and a vertical shift of 7 over 3.
All right, let's talk about the general formula for a sinusoidal function. Now, just because it says sine there, it doesn't have to be sine. It can be sine or cosine, but it's called a sinusoidal function.
Okay.
Okay? Now, A is the amplitude. That's what's 5/3.
Okay.
The period is related to B. Well, first of all, let me ask you, is this the general formula you've been taught? Because there are a couple. In other words, sometimes I run into systems that teach it like this. They put the B inside of the parentheses.
Actually, no, we haven't learned it that way. I forgot what the formula is right off my mind, but I know it's not that.
All right. It must be. And there's even a third way, and that's in one state. I live in Colorado, and there's 3 different school districts, and one of them uses this one even. And it doesn't matter which one you use, but it's very important to determine period and phase shift depending on which one of these you're using. The top one's the most common, so that's what I'm going to use since you don't know if it's different than that. All right, so.
Okay, that works.
Okay, if the period is pi over 4, well, we know that B is 2 pi over the period. Okay, which also means that the period is 2 pi over B if you happen to be going the other direction. But in this case, they give us the period. Okay, so what's B?
2 pi over period. So it would be 2 pi over pi over 4.
What's that number?
1 second. 2 pi over pi over 4. Would I flip and multiply?
Yes, absolutely. You need to know that that's the first thing to do. Whenever you have a fraction in the denominator, that's what you should be thinking.
So it would be 8 pi over pi.
Which is just 8.
Yeah.
Okay, so we have our B, we have our A. What is our C? What's the phase shift?
pi over 3.
To the right. And it matters. In other words, let's make sure you understand what phase shift, because this is the first time you and I have ever talked about sinusoidal functions. Okay? That's sine over x. Or, I'm sorry, that's sine of x. Well, what if I put a phase shift in there so that it said sine of x minus pi over 4. Okay? Well, let's label this graph. That's 2 pi. That's pi. That's pi over 2. That's 3 pi over 2. You want to get really good at quartering these graphs because you have to do it so frequently. Okay? Now, when I say y is sine of x minus pi over 4, I'm saying there's a phase shift. How much is it and which way is it?
Negative pi, so...
No, it's actually, the standard is x minus h. Or, in our case, x minus c. So, our phase shift is a positive pi over 4, meaning we move it right pi over 4. So we take this exact curve and we find where pi over 4 is, and we're going to start it there, and our period isn't any different. It's still 2 pi, so we have to go to 9 pi over 4. And we're going to draw our curve, and it's going to look something like this, if I can find my starting point. That's what a phase shift of pi over 4 to the right looks like.
Okay.
In other words, one way to do your phase shifts is to, and I did them this way for years until I actually found out that there was a little bit easier way to do them. But one way to do them is to draw the curve that has not been phase shifted and then just move it. The new curve is basically parallel. I mean, it's not really called parallel, but you know what I mean, right?
Yeah.
The new curve, the blue curve, is parallel to the red curve, only it starts pi over 4 to the right, and it ends pi over 4 to the right. Now, in reality, both of these curves don't end. They all go on forever. In other words, the sine curve goes like that in that direction, and it keeps going like that in that direction. So the blue curve also does that. Okay, in other words, the only thing I drew the first time was one period of the blue curve and the red curve. But that's what phase shift means. And it's very important that you know which direction and the amount. Now, let's go back to this. If this is our standard formula, then the phase shift is C. Okay? But let me give you this equation. Y equals 2 sine of 3x minus 6. Okay? Now notice that my multiplier is inside the parentheses. So my phase shift here is not 6. I have to get this b outside the parentheses, meaning I have to factor it out. So I would change that into this. Same equation, but completely different. Now b is 3, which it still was here, but the phase shift is 2. It's not 6. So it's very important that if you have a multiplier of your x, whether you know whether it's inside or outside the parentheses.
Okay.
And it can be useful in both cases. I've seen problems where it really is better if it's inside the parentheses, and I've seen problems where they work out a little better if it's outside the parentheses. So one is neither better than the other, but it makes a huge difference when you go to calculate phase shift. It doesn't really matter for B. Notice that B is 8, whether that B is inside the parentheses or outside. The thing that matters the most is what happens to the phase shift. If the B is outside the parentheses, then the phase shift is C. If the B is inside the parentheses, the phase shift is C divided by B.
Okay.
Well, in this problem, they've pretty much given us everything. Okay? So A is 5/3. That's the amplitude. We calculated that B was 8 because the period is pi over 4. And we figured out that the phase shift is pi over 3. And a vertical shift is plus 7/3. There is the sinusoidal function that fits those 4 variables.
Okay.
Now, when you're dealing with sinusoidal functions, I mean, this is a hard topic. We're not going to cover this in one session. Okay? You need to be able to go both ways. In other words, if I give you these 4 parameters, you need to be able to come up with the equation that is proper. But also,
another way around.
Yeah, if I give you a curve and I say, tell me the sinusoid function that corresponds to that curve, well, let's just take the one I just wrote. What's A?
A would be 2.
What's B? Remember, B is 2 pi over the period. And that's a very extremely relationship that you want to memorize. If you don't memorize that, you can't get any of these right.
Okay.
Okay, so that's the most important one to memorize because it's the hardest. So in my example, what is B?
2 pi over 1.
2 pi over the period. What's the period in my drawing?
How many times it occurs? Or no, where it first happens.
The period is the distance from where it begins to where it starts again. In other words, if I were to keep drawing this, the period is either peak to peak, valley to valley. Exactly. So the period in my drawing is pi.
Okay.
Okay, so B, therefore, is what?
It would be 2 pi over pi. Then that would just be 2, right?
2, correct. What is C? The phase shift.
So that's how it gets shifted compared to the regular formula.
Yes. Is this the regular?
I have no idea.
It is. That's exactly what y equals sine x. Well, it's not quite the regular. In other words, y equals sine x would almost look like this curve, except this would have a period of 2 pi. So we need, in other words, at the moment, our curve looks like sine of 2x because we figured out that b has to be 2 if our period is pi. and A has to be 2, so let's stick a 2 in front. Now, the question is this curve phase shifted from just sine of x? No, it is not.
No.
They both begin at the same place.
And then 0.
Sine of x might look like this, but they both, it's very important to understand where these curves start. Sine starts at 0 and goes up to its maximum immediately. Cosine starts at its maximum, goes down to 0, and then goes down to its minimum. So this is cosine. And it's important that you are able to recognize that. In other words,
Okay.
I actually could define this curve as a phase-shifted cosine curve. Notice that it looks exactly like a sine curve, so it would not make any sense to do that. And in fact, the general formula you kind of follow is that you use sine or cosine depending on which one results in the least phase shift. Well, if I use sine, I have 0 phase shift. So at the moment, my function looks exactly like that. Is there any vertical shift?
No.
That is my function of the curve you're looking at.
Okay.
Now, I could also call this a cosine curve. Okay? In other words, if I wrote this as 2 cosine of 2 times x minus pi over 4, notice the formula is not much difference. A is the same, B is the same, but I've thrown in a phase shift of pi over 4. Well, there's pi over 4 on my drawing. In other words, if I were to take the cosine curve and move it pi over 4 to the right, this is exactly what it would look like. It would start there, it would end up there. And then when you draw the rest of it's going to go through there. So when you talk about sinusoid function, there are literally an infinite number of functions that fit the same graph. Just like this graph is described by that function, but it's also exactly described by that function. Now, I would always use this function because, like I said, you use the least amount of phase shift. But part of the problem here is that you don't know whether it's sine or cosine, especially if they start giving you word problems. If they give you word problems like Ferris wheel problems, okay, and you have to figure out whether it's going to be sine or cosine, well, then it's very important that you understand the graph of the two basic functions, sine and cosine, because sines start at the midway point and they go up to their maximum. Cosines start at their maximum and they go down to 0. So let's draw a Ferris wheel, okay? And let's say people are getting on right here. And I want to model this Ferris wheel with a sinusoid function. Well, what happens? People get on and they go up to the maximum. That looks like sine to me.
Okay.
What if the person got on down here? In other words, what if the platform for getting on was down here? Well, now they get on at the bottom and they go to the top Well, that looks like negative cosine. Notice that what I've drawn here is the cosine curve reflected over the x-axis. Okay, well that is y equal negative cosine of x. Well, if I have a Ferris wheel problem and I want to model this problem, they're getting on at the bottom right there, and they are proceeding to go higher to the top right there, exactly what the negative cosine function does. So when you are modeling real-world problems, it's very helpful to know whether you're starting in the middle point going up, starting in the middle point going down, starting at the bottom going up, starting at the top going down. And it will tell you as to whether you need a negative sign in front and whether you should use sine or cosine.
Okay.
We got about 3 minutes. Do you have any other problems, Taylor, specific?
Inverse trig functions, like,
Okay.
so would I have to use a unit circle?
Okay.
The ones I have no idea how to do are like arctangent, negative, root 3 over 3. I have no clue on how to find that out.
When you say arctangent, that's the same as that. You could also say inverse tangent. Okay? Let's talk about inverse trig functions. If I say the sine of 30 degrees is equal, what is that equal to?
That would be 1 over 2.
If and only if the inverse sine of 1 over 2 is 30 degrees. In other words, we take trig functions of angles and we get ratios. We take inverse trig functions of ratios to get angles. So let's say you have a triangle, a right triangle, and it's a 3, 4, 5 right triangle, and I want to know this angle right there. Well,
Okay.
I can use inverse trig functions to find that angle. In other words, and I could use pretty much any of the 6, but I'm going to say this angle is equal to the inverse tangent of 3 over 4, right?
Yeah.
That's what it means to do inverse. Now, let's address your specific problem. If I draw my 2-unit triangles here, and this isn't theta, that's 30 degrees. What is the tangent of 30 degrees?
1 over 2. Actually, no. 1 over pi, or root 3. 1 over root 3.
Now, you have to rationalize that. In other words, that's not a satisfactory answer because the denominator is irrational. So how do you rationalize that answer?
Times root 3.
Times root 3 over root 3. In other words, I can only multiply a fraction by the number 1 without changing it. Okay? So now I get the tangent of 30 degrees equals root 3 over 3. What's the answer to that question right there?
What do you mean?
What is the inverse tan of root 3 over 3?
I don't know my tangents, but I know my sines and cosines.
Right there. You don't need to know your tangents. In other words, if the tangent of 30 degrees is root 3 over 3, then by definition, the inverse tangent of root 3 over 3 has to be 30 degrees. These two things go together If and only if.
Okay.
In other words, always, if the tangent of an angle is equal to some ratio, then the inverse tangent of that ratio is equal to the angle.
However, my teacher makes me put it in radians, so that would be pi over 6, right?
Yes.
Okay.
In other words, I can replace that with pi over 6. I can replace that with pi over 6.
Okay.
Taylor, I have a 3:30 that I'm 2 minutes late to, so I'm...
Okay, sorry.
It's all right. It's my mistake, actually. So I will talk to you next time.
Okay, I'll talk to you tomorrow.